In algebra, we have a friend called Slope Dude. Slope Dude helps us remember the slope of horizontal and vertical lines, and he also helps us keep track of the difference between positive and negative slopes. Let's go ahead and see what Slope Dude has to teach us.
Welcome to the adventure of Slope Dude. Meet Slope Dude. He loves to ski. We are going to follow him and he'll teach us some important aspects of slope. This is the course he's skiing today. Again, what he says will teach us about slope. You need to remember that Slope Dude always skis toward the right or eastward. When he starts out, he's going uphill. It's hard work. He says puff, puff, positive as he goes up the mountainside. Puff, puff, positive, puff, puff, positive, puff, puff, positive. Now he's at the top. It was puff, puff, positive all the way up the mountain. But now he can look forward to the downhill. On the way down the mountain, he says, nice, negative, nice, negative. And now, after the downhill, he's in for the hardest part of the ski run, the long, flat part. He says, this is zero fun. This is zero fun. This is zero fun. This is zero fun. And as he finishes the flat part, he doesn't see well ahead, and all of a sudden, he comes to the edge of a cliff. It's straight down. So frightened is he that he says the worst curse word possible in math and in algebra. Undefined. This has been the adventure of Slope Dude. Remember always what he said during his ski trip. Up the hill or up the slope, he said, puff, puff, positive. On his downhill run, he said, nice, negative. On the long, flat part of the course, he said, this is zero fun. And finally, when he went over the vertical cliff and went straight down, he yelled the worst curse word of math and algebra, undefined. The uphill is a slope with a positive number, the downhill is a slope with a negative number, the flat part is a slope of zero, and the straight up and down or vertical part is undefined. This has been the adventure of Slope Dude. Thanks for viewing.
Okay, so Slope Dude helps us remember that when a graph is going up from left to right, that's our puff, puff, positive. We should always have a positive slope. When our graph is going down from left to right, that is a nice negative. Our slope should be negative. Horizontal line is zero fun, slope of zero. And then a vertical line, slope of undefined. We can use Slope Dude to do some really interesting matching of equations to graphs. Or at least I think this is really interesting. So here I'm giving you a list of 4 equations. Y equals 2x plus 1, y equals negative 2x plus 1, y equals 1/2 x plus 1, and y equals negative 1/2 x plus 1. All of these have a y-intercept of 1, so I can't distinguish my graphs using the y-intercept. I'm going to have to figure out which equation matches which graph just by looking at the slopes. The first thing I'm going to do is identify what Slope Dude would tell me about which of these graphs are puff, puff, positive and which equations. So this is obviously a positive number. This is a positive number. So those will be matched with puff, puff, positive graphs. Here is a puff, puff, positive graph and another puff, puff, positive graph. Now all I need to do to match my equation with my graph is figure out which of these 2 graphs has a slope of 2 and which has a slope of 1/2. A slope of 2 means when x goes up by 1, y goes up by 2. A slope of 1/2 means when x goes up by 1, y only goes up by 1/2. In fact, when my slope is a fraction, that means my graph is going to be flatter. Y is not going up by very much when x goes up by 1. A fraction is going to be flatter, whereas this number 2 is steeper. My slope is bigger. Y is going up by more when x goes up by 1. That helps me match that this is the graph of y equals 2x plus 1. It's puff, puff, positive and pretty steep. And this is the graph of y equals 1/2 x plus 1. Also puff, puff, positive, but flatter because of that fractional slope. Next, I am looking at my nice negative equations, negative 2 and negative 1/2. So those are my graphs that go down. They slope down from left to right. That is a nice negative, just nicely going down that slope. Again, my slope of -2 will mean when x goes up by 1, y goes down by 2, whereas the slope of -1/2 is going to be flatter. When x goes up by 1, y only goes down by 1/2. So for negative lines as well, fractional slope will be flatter. This is y equals -1/2 x plus 1. This one is y equals -2x plus 1. So 2x, -2x, steep. 1/2 x, -1/2 x, flat. Let's go on to the next set. Isn't this fun? Next set. Let's look at the puff-puff positives. Puff-puff positive of 2, 6. Those are my two positive slopes. And then my two positive graphs are this one and this one. Now I can talk about the effect of the 2 and the 6 as the slope, but notice I can also distinguish these two just using the y-intercept. The y-intercept here is 0, 4. The y-intercept here is 0, -4. 0, 4, 0, -4. I can therefore match these just using the fact that a positive y-intercept and this one has a negative y-intercept. This is y equals 2x plus 4. This is y equals 6x minus 4. Notice that what I talked about the steepness of a graph applies here. A slope of 2 means when x goes up by 1, y goes up by 2. A slope of 6 means when x goes up by 1, y goes up by 6. That's a lot more. So a slope of 6 will have a steeper graph, and we see that here. So we could have hopefully distinguished these two even if they had had the same y-intercept, knowing that a slope of 6 will be a steeper graph than a slope of 2. Nice negative is next. My negative slopes are -2 and -6. So these are my two nice negative graphs going down from left to right. I again am able to distinguish between my two nice negatives with the y-intercept. Here's a y-intercept of -4. So that one's right here, negative. Here a y-intercept of +4. So the y-intercept allowed me to see which was which. This is going to be y equals -2x minus 4. Negative slope, negative y-intercept. Here I have a negative slope, y equals -6x, and a positive y-intercept, y equals -6x plus 4. However, let's apply what we talked about with the slope. A slope of -2 means when x goes up by 1, y goes down by 2. A slope of -6 means when x goes up by 1, y goes down by a lot more. It goes down by 6. That means this bigger slope is going to have a steeper line. Even if these had had the same y-intercept, I could have identified the difference between the two by looking at a steeper graph for the slope of -6 versus -2. Slope can be really, really helpful when you're checking your work, and it can also allow for some really fun puzzle challenges matching equations to their graphs.